Okay, everyone, let us now try to solve the first problem. So we need to find the equation of a hyperbola with a center at the origin, one focus at 3, 0, and one vertex at -2, 0. So and also graph the equation. Okay, so what we always do, let us plot our given. Okay. So what do we have? We have the center at the origin. Okay, center at the origin, very convenient. Then the next one, we have one focus at 3, 0. Focus at 3, 0. So 1, 2, 3, and we have that 3, 0 focus. And then we also have one vertex at -2, 0. So 1, 2. Okay, so -2. Okay, so what are the variables that we need in order for us to get the equation? So we need A and B, right? So do we have an A here? So the A is from the center to the vertex, right? So we know that because we are already given this -2, 0, which is a vertex. Okay, so -2, 0. So therefore, our A is the distance from the center to a vertex. So therefore, our A is 2, right? So it is the absolute value because we are talking about a scalar value, which is distance. So we don't need a sign here. So okay, so we already have our A. Now, another one is the B, I mean. So we need to find C first. So C is distance from the center of a hyperbola to a focus, right? So we also have that here. We have 3, 0. Okay, so if we find the distance there, we have 3, right? So we have C is equal to 3. Now, if we recall, what is the relationship between A, B, and C for a hyperbola? We have B squared is equal to C squared minus A squared, right? Okay, so if that is the case, we can then substitute. We have 3 squared minus 2 squared. Okay, B squared is equal to 9 minus 4. B squared is equal to 5. And then B is equal to positive negative square root of 5. Okay, so there you have it. So our B is a positive negative square root of 5. So since our focus and we also have a vertex here in the x-axis, we can say that our transverse axis is also here on the x-axis, particularly this part right here, right? Because on the other side of on the positive x-axis, our vertex is at 2, 0. Okay, so if that is the case, then the form of our hyperbola, the standard form of this particular hyperbola is x squared over a squared minus y squared over b squared, right? It's equal to 1. So if we substitute our values here, so what do we have? So x squared all over a squared. So what is a? So 2 squared minus y squared all over b squared, which is the square root of 5 squared. Now that would be equal to 5. Okay, so if we rewrite this again, so 4 minus y squared over 5 is equal to 1. So this is our equation. This is the equation of our hyperbola. Okay, very cool indeed, right? So if we want to graph this manually, so actually we need to get, let's use a calculator here. Oh wait, so just wait a second here. So if we get the square root of 5, we will get 2.236. So 2.236, let's graph that out. So we have 1, 2, and let's say 3 right here. So 2.236 would be right here. And 1, 2, 3, and that would be approximately right here. So if we draw an imaginary box right here, so this is a technique for drawing hyperbolas. If you draw an imaginary box, connecting our A and B here. So this is B, right? This is the co-vertex, and these are the vertices on the x-axis and the co-vertex on the y-axis. So you can start by connecting these two corners right here, connecting these two corners right here, you can connect these two corners right there, and those will be our asymptotes. Okay, those will be our asymptotes, and then you can then draw approximately. You can approximate your hyperbola using this framework that we've created here. Okay, so there you have it. If we take a look at the accurate representation using a graphical tool, we will see this one. Okay, so x squared over 4 minus y squared all over 5 is equal to 1. So that's exactly what we got. So we are correct. Okay, so see you in the next video. Thank you for watching.